Namaste, welcome back to Sthita Pragna channel and hello to all the data enthusiasts. Did you ever wonder how companies make sense of gigantic amounts of data like millions of customer orders, health records, or even the secrets of the universe? Welcome to the world of Apache Spark. In today's episode, which will be the last episode in this chapter of data engineering, we will see exactly how Spark is used in real data engineering pipelines, what a data scientist's workflow looks like with Spark, and why this open source tool is revolutionizing analytics. We will break it all down step by step using diagrams, industry examples, and easy to understand explanations. Now, let's start with how can you use Spark. Let's start from the top. Whether you are a data engineer or a data scientist, as I mentioned in one of the previous video, Spark is your Swiss army knife for tackling big data challenges. You can use it for everything from cleaning and transforming massive data sets to running machine learning models to building real-time dashboards. Let's see how a typical data pipeline works in a company using Spark. Imagine you are a data engineer at an e-commerce business, and what is your job? To make sure all data from web clicks to transactions to customer reviews is available, clean, and ready for analysis. And here's how Spark fits into this particular flow. I'm not going to draw, I will show you the diagram. Let me zoom it a little bit. So let's break down this diagram. You can see the ingestion part here. Yeah. Spark can ingest data from any source. I have showed you that the diagram, right, in the previous video. Yeah, which shows Spark can consume data or ingest data from pretty much any source. That includes databases, CSV files, JSON files, streaming platforms like Kafka, cloud storage like S3, you name it. This is the raw data stage. Sometimes it is called staging or landing or bronze zone, whatever you want to call it. Okay. And an example would be, let's say you are pulling daily sales records from your website and sensor readings from your warehouses. And step two, before using this data, you need to ensure it's accurate and safe. So how do you do that? You apply data quality rules, DQ rules. Not all companies do that, but some companies do that. What are some of the data quality rules? Well, it's like, is every date formatted correctly? Are social security numbers obfuscated for privacy? It just means that did they replace actual social security numbers with the stars and etc. Do all required fields exist? So these are some of the data quality rules, and this is the pure data, or in Databricks terms you will call it silver zone. Example would be, imagine removing all transactions with missing prices or hiding sensitive customer details before anyone can access them. And then you have the transformation, right? You transform the data. How do you transform the data? By joining multiple data sets or aggregating data, for example, total sales per day, or you apply custom functions or business logic, whatever the business wants, or running machine learning algorithms. And the result is rich data. This is also known as gold zone. Example would be, suppose you merge web analytics with order data to understand how marketing campaigns drive sales. And finally, you publish or load the data. That's what you are seeing here. Load it into a data warehouse for BI reporting, or feed it to dashboards, or share it with downstream systems or APIs. Now, it's actionable data ready to guide business decisions. An example would be, your published dashboard, which helps management see which products are trending or alerts them to low inventory. Okay, so what makes Spark special for this workflow? Because Spark architecture is distributed. It runs across a cluster of computers for speed and fault tolerance. It works in memory, so processing is blazing fast. It supports structured, which is SQL and data frames, and unstructured text, logs, images, data. Now, let's take an example of Spark in a data science scenario, right? Let's step into the shoes of a data scientist for a minute. Here, the approach is more interactive and exploratory. Data scientists use Spark to test hypotheses, build models, and visualize data, all from their favorite notebook environments. If you don't know what notebook environments are, don't worry. We are going to install it in the next chapter. You will see what they are. Anyways, so I am going to show you a diagram, and I will show you what the data scientist would be doing. Let's see walk through this sequence step by step. First step would be, where do you think is it? As I said, notebook. Where is the notebook? You can see that here. Notebook is nothing but it has cells. You write your code and execute one at a time there. So that's where the data scientist is writing their code. Right? They type their code in a notebook, and some of the examples of notebooks are Jupyter, which we are going to install, Zeppelin, which we are going to install, Databricks, which we are going to install. And you might be thinking, like, how many are we installing? Well, as I said, you are going to learn everything about Spark. Not all companies use the same way to write. Some companies uses Glue to write their Spark code. Some companies will use Databricks to write their Spark code. Some companies will use maybe a PySpark IDE to write their Spark code. Some companies just executes their scripts from shell. So you name it. There are different ways you can do that. And guess what? I am not leaving any leaf unturned. I want you to know everything, and you can, and you don't have to know it 100%. As I said, all you need to know is 20% of it, how it works. The nitty-gritty details, how to execute it, comes later on. Once you get the job, these days you ask ChatGPT everything. But how you ask ChatGPT is the main goal, because if you don't know how to ask ChatGPT, it doesn't matter. Even if you have the quantum computer with you, you can't do anything, right? In order to use the quantum computer, you need to know how to use it. You don't need to know more details. But same thing here. You are going to learn everything. You are not going to master it. Okay, there is a difference between those two. You are not going to master all of this, but you are going to learn how to use them. That's what is needed anyways these days. uh, Once you get the job, it's very easy to do the work these days. You can use GPTs very easily and get the work done if you know what you are doing. That's what I'm going to teach you. All right. Now, let's take an example code that we have seen in one of the previous one. There we wrote code in RDDs. Now let's write code in using data frames. This is how it's going. I'm going to create a data frame, and I will say Spark read CSV, and then put a bracket. There are so many options for this, but I'm not going to go into all of that. I am just telling it to read an S3 file, and I will say my bucket slash data.csv, and then I'm going to say it has a header, which I'm going to say true. That's it. You are reading a file called data.csv and telling it has header, so that data frame can have columns from here. Let's assume this is what he wrote in his notebook. Got it? Notebook is going to then, you can see it here. Here it says this is the user. Actually, this is the data scientist. Oops. This is the data scientist, and he is using the notebook and typing in some code. Let's assume he wrote some code in Python. and Python code that loads data from a data source, and here is the piece of code that loads data from a data source. Okay, now notebook sends a command to the Spark engine, which you can see here. This is the Spark engine. Spark connects to the storage system, which you can see here through here. It is connecting to the storage system, and it loads the requested data, which you can see that here. The data is loaded and available for use in the notebook. Okay, so the data from here to Spark and from here to the notebook, you can see that. Then user applies, which went to the user through the notebook, obviously, and then the user applies transformation or action, which you can see it in the loop. And an example of that would be, I will just write it, it will be easy. You have the data frame, but you are not doing anything. Data frame dot show is like viewing the data. It's an action you are implementing. What are actions? We'll talk about them later. Or maybe, run a machine learning algorithm or create a new calculated column. Here we are just trying to show the data, but he can do anything. The transformation, which you can see here, right, is executed across the cluster, which you can see that he is trying to apply the transformation or an action. This is an action, like showing the data, which we did. And where did it go? You wrote that in the notebook, and notebook is going to ask Spark to apply this transformation, and then Spark is going to do apply that, and in case of returning the data, it is going to send it to the notebook, and then it goes to the user and returns the data. So this goes on in a loop as needed, right? The data scientist iterates, loading new data sets, refining transformations, analyzing results until they have the answers they need. And that's what makes Spark so great for data scientists. It lets you interactively explore huge data sets, test new ideas, and build models, all without worrying about the complexity of distributed computing. They don't need to know all that, do they? Let's make this concrete. Here are just a few ways Spark is being used in the real world. Now you know from a data scientist perspective, you learned it. Now let's see some real examples in the real world. Okay. Predict, predicting, predicting restaurant quality. Who or where does it happen? This example is from nceatery.com. They collect health inspection data from all over North Carolina. Then they clean it, standardize it, and combine the data with Spark. Then they apply machine learning to predict which restaurants are improving or declining in quality. Then they publish results to help people find safe places to eat. That's what NC, North Carolina Eatery.com does. And another example would be accelerating healthcare analytics. And who is doing this? Lumeris. They ingest thousands of CSV files from S3, which helps them build healthcare compliant records, and then enables doctors and analysts to gain insights, improve patient care, and comply with regulations. And another example would be like analyzing scientific data at CERN. You might have heard about this. This is the European Organization for Nuclear Research. They process data from the world's largest particle accelerator, which they handle up to 900 GB of experiment data. Guess what? Per day. Scientists use Spark with custom apps and Jupyter notebooks to uncover new physics insights. And there are so many other cool examples like interactive data wrangling tools like Databricks, IBM Watson Studio, monitoring quality of video feeds for major TV networks, detecting cheating in online games in real time. Riot Games uses that. Fraud detection, customer segmentation, recommendation engines, you name it. Why do data pros love Spark though? We already know some of the answers. Here are some highlights if you are interested. It's easy. It's intuitive API and it's intuitive APIs like you can use Python, Scala, Java, SQL, or R. And it's declarative programming. Focus on what you want, not how you do it. And it's unified engine. It has batch, streaming, machine learning, graph analysis all in one place. And the performance. It's fast, in-memory computation with optimizers like Catalyst for SQL and Tungsten for execution. And it's open source and it's thriving. Massive global community, tons of resources, regular updates. And who all use Spark? You already might know the answer. Data engineers like us who build and manage ETL pipelines, transform and publish data, ensuring quality. Then data scientists explore data, build models, analyze trends, drive innovation, and also machine learning engineers. They train, tune, deploy machine learning models at scale. And you might be wondering if you are already working, you know that in many companies these roles overlap, especially at startups and even mid companies. But no matter your job title, Spark is your toolkit for anything big data. Okay. And popular use cases for Spark are processing massive data in parallel, interactive analytics and ad hoc queries, building and training ML models with ML libs, streaming data pipelines for real-time processing, social network and graph analysis. You name it, there are plenty of them are there. So that being said, let's wrap it up. Apache Spark is the engine behind the data revolution, powering everything from business dashboards to cutting edge science. Whether you are prepping data for a report, training an AI model, or analyzing streaming logs, Spark can do it all at scale and with lightning speed. Do you have questions regarding any Spark project? Drop it in the comments. Like, subscribe for more practical data engineering and data science content. And guess what? This is the end of this section or chapter 1. We had how many? 6 episodes. We are going to start a new chapter, and that is going to be the installation and setup of Spark. When I say installation setup for Spark, it's not limited to Spark. Uh, Trust me when I say this, you can go and check it as well. You have not seen on any YouTube channel where they are going to set up and install this many tools. And I mean, this is called a masterclass for a reason, right? We are going to pretty much install anything and everything that has to do with Spark. Trust me, including that includes somewhere we even set up Airflow, we set up Docker, we set up Databricks. We set up MySQL database, I think even PostgreSQL database, a couple of other Cassandra, MongoDB. See, I want you to learn everything, so am going to include. I think, as I mentioned in the introduction video, I have gone through 30 plus books related to Spark, data engineering, Python, Scala, Java, and all. So, all that I gathered, and I'm going to present it in a easy to understand and following way. So installation setup is going to be huge. We are going to pretty much set up so many ways. So you can pick whatever you want, your favorite from them, or if you want to try all of them, you can do that. So let's not waste any more time. Thanks for joining me for this deep dive into Spark. Keep crunching that data, and I will see you in the next chapter, next episode. Keep sparking. Peace out. Love you all. Have a great day.